At this point, we will show you how to create fuel sensors. As you know, there are two popular ways of monitoring fuel. One, we can monitor it directly via the CANBUS of the vehicle. Or two, we can monitor from an external fuel level sensor that is linked to the tracker. In this case, I will show you how to add fuel sensor for data that is coming from the CANBUS. First, I right click on the vehicle, go to sensors, add a new sensor. Function, I want a fuel sensor. So I click on the drop down, go to fuel sensor, then the name, I choose to duplicate the name of the function, fuel sensor, and I can do the same thing for the description. By default, it is dedicated, which means that we are reading values that are changing frequently, increasing or decreasing. The next, in the field section, I am going to look for the data parameter that is sending the CANBUS value for fuel. So I click on this button, then I can click below and find this. That's the fuel in liters. So from this data parameter, we are going to monitor the fuel values that is coming from the CANBUS. So the next thing to do is to add the unit name, which is liters. I can decide to write L or total liters. I will move directly to the conversion formula. Here, according to the documentation of the hardware provider, it says that we are supposed to divide the fuel that is coming from the CANBUS by 10. Therefore, I am going to divide it by 10 and then test this formula. So if this data parameter is sending us 730, as we saw, let's see what it will give us. So test, therefore, if this data parameter is 730 in value, it is going to give us 73, which makes sense and easy for the fleet manager to understand. The next thing I would like to do after the conversion formula is to increase my refueling and drain threshold. This will be based on the size of my tank. In this case, I would like to make it 5, so I can detect any refueling if the fuel triggers from 5 and above. The same thing happens for the drain. Next, I will decide to make this 5 as well, and this will be based on the size of your tank and your customer requirements. You can read more about it on our documentation page. The next to do is to increase the frame for analysis difference. I will make this 3, and this to smoothen the graph of reports, I can decide to make this one 3 as well. Now I will come to these checkboxes. First is to consider speed. If this is checked, the system will take fillings and drains into consideration only when the speed is 0. But then if I uncheck that, it means that even if the speed is maybe 5 or 10, the drains and fillings will still be considered or taken into account. The next thing is to filter null value. I can decide to show it in tooltips. I can decide to save it in history, or I can decide also to remove symmetric fillings or drain. For example, if the vehicle is moving or climbing a hill or descending from a steep hill, there will be some fuel changes in the tank. To prevent false drains or false filling alerts, we check this so the system can smoothen your graph. I will save now. And as you can see, we have our fuel sensor here, which is among the sensors that we have created. Now let's move to where the vehicle is. I will hover this vehicle and I can see in the tooltips that the fuel sensor is 65 liters. When I click, I can see it is 65 liters. When we were creating the sensor, we could see that the vehicle was moving very fast, and as a result, we can see a real-time decrease in the fuel in liters.